All right, just want to take a couple of minutes to just very briefly go over second fundamental theorem of calculus. I'm going to do another video where I demonstrate it or kind of prove why it's true. But for now, let's start with this second fundamental theorem of calculus. It says that the first derivative of the definite integral a to x of f of t dt is equal to f of x. And it just bothers people so badly. Now, what I want to tell you is that we just have a slightly different situation that's come up, and we're using the variable x as the upper limit of integration, right? So to avoid confusion here, we put in t. I think of t like temporary. T like temporary, because what we're saying is that this value x is our upper limit of integration. Okay, so why would you use that? Well, possibly, and it is possible, you have a function, and that your function is an integral, is a definite integral. So it's the definite integral from I don't know, let's say 0 to x of, I don't know, 2t squared plus 4t plus 1 dt. Important here that these things have to match. So dt in terms of t. So we're saying this is this function. For whatever reason, you're some chemical producer or something, and you're going to use this function over and over and over and over and over again. So you want a quick way to be able to take f of 9. So so I say, what's f of 9? You don't have to say it's the definite integral 1 to 9 of 2t squared plus 4t plus 1 dt, and then do the integration. Maybe you put this into a calculator, and this is just how you're going to find your function over and over and over again. So this becomes really, really important, but that's the reason that we have it. So here I could take f of 3 or f of 5 or f of apple pie. So this is the reason that we're doing it this way. From there, it gets really easy. And if you just look at this, and this is the way I'm looking at this. I'm like, ddx, right? And then we have this integration. These things cancel each other. These things cancel each other. That's how we get to just f of x. So just some really quick examples. And then after that, in a separate video, I'm going to explain why this is true if you need to know. But for now, if you're taking especially if you're taking the AP exam, know this. If you're given f of x is equal to the definite integral from -2 to x of t squared minus 2t dt, and you're asked the following question, you're asked, what's the derivative? What's f prime at x? What you can feel very comfortable doing is just substituting in, given this, we have just x up here, and there's some different stuff, and I'm going to talk about that in a different video also. But assuming that you have just x here, then you can feel very good about saying that, 2x, and that is your answer. And now you're like, Charlie, is that it? Yeah, that's kind of it. I mean, let's do another example. So we're given this function, and we're told that f of x is equal to the definite integral. So this is our function. It's the definite integral from 1 to x of t squared over t squared plus 1 dt. You can feel very comfortable here if asked what's f prime at x, of just saying it's x squared over x squared plus 1. I think I can kind of hear you going, dude, is that kind of it? Yeah, that's kind of it. I mean, that's kind of how this works. I told you before, I am going to do another video explaining it a little bit, but I can prove that this works. I can demonstrate that this works, for lack of a better term. Let's do one more example. Say f of x, my function, is equal to the indefinite integral from -1 to x of square root of t to the 4th plus 1. Well, guess what f prime at x is? F prime at x is the square root of x to the 4th plus 1. I'm just substituting in those values. When you watch the next video, you'll really get why this is true. But if you don't go to that video, I want you to know that as long as the integral has the upper limit of just x, you can just substitute like this when finding the derivative based on the second fundamental theorem of calculus. What I'm going to do in the next video is I'm going to prove this out using the first fundamental theorem of calculus. I'm actually going to what I'm going to do is this. I'm going to actually integrate this, and then I'm going to do the fundamental theorem of calculus and show you that if I did that and then differentiated, I would get that thing back. So hope this is really helpful. If you have any questions or comments, please let me know. This does show up on the AP exam, usually in the multiple choice, and it's going to 3 or 4 questions, and you might as well get them. It seems pretty easy to me. So thanks for watching. If you have any questions or comments, let me know. Oh, subscribe.